This video is about writing the equation of a line in point-slope form and slope-intercept given 1 point. So point-slope form is a new form that we haven't really talked about yet. And in point-slope form, you always need a point and the slope. So point-slope form is y minus y1 equals m times x minus x1. So we're always going to put y1 and x1 is going to be our point that we're going to put into the equation. We always use the opposite sign than the point has. And our m is always going to go in front of the parentheses, which is our slope. So in number 1, we have the point 47 and a slope of -2. So when we substitute, we would have y minus 7 equals -2 times parentheses x minus 4. So notice that x and y were positive numbers, so when we substitute in, they became negative signs. The slope, however, always keeps the sign that it originally had. So in number 2, when I substitute, I would have y plus 1 equals my slope 3/4 times parentheses x minus 3, because 3 is my x-coordinate and -1 is my y-coordinate. So they get opposite signs. 3 was positive, so it becomes negative in the equation, and -1 was negative, so it becomes positive in my equation. It's always going to switch the sign that it has. So in number 3, when I substitute, I have my x-coordinate and my y-coordinate, so I would have y plus 3 equals 5 times parentheses x plus 1. In number 4, I have my x-coordinate and my y-coordinate again, so I would have y minus 0 equals -1/6 times x plus 1. Because there's a 0 there, you could just write it as y equals -1/6 times x plus 1. You don't need to put the 0 in if it's just a 0 for the coordinate. So now we're going to talk about how do we move from point-slope form to the slope-intercept, which is the one we've seen more. So what we do is we have to distribute into our parentheses, and then we need to solve for y. So let's practice. This equation's already in point-slope form. Y minus 10 equals -3 times x plus 2. We're going to distribute -3 into the parentheses, so y minus 10 is equal to -3x minus 6. And then to solve for y, we need to move the number to the other side. So we're going to add 10 to both sides. So y equals -3x plus 4. So let's practice writing in point-slope form and then moving to slope-intercept. So to write in point-slope form, remember we're starting with y minus y1 equals m times x minus x1. So when I substitute, I have y minus 5 equals -2 times x plus 1. And to move to slope-intercept form, I have those two steps then. So I'm going to distribute. So I get y minus 5 equals -2x minus 2. And I'm going to add 5 to both sides, so y equals -2x plus 3. So the green equation that we start with was our point-slope form equation, and the equation we ended with then was our slope-intercept form. So let's try another one with number 7. When I substitute my point for point-slope form, I have y minus 9 equals 1/2 times x minus 4, because they both get the opposite sign, and since they were positive, they become negative. So I'm going to distribute the half into the parentheses, so y minus 9 equals 1/2 x minus 2. And then I can add 9 to both sides, so y equals 1/2 x plus 7 is now my slope-intercept form. So now we're going to write our equation in point-slope form and then move to slope-intercept so that we can graph it. So in number 8, we have the point -5 as my x-coordinate and 2 as my y-coordinate. So we're going to substitute those into the equation. So we now have y minus 2 equals 3 times x plus 5. To move to slope-intercept, I'm going to distribute first, so y minus 2 equals 3x plus 15. And then I'm going to add 2 to both sides. So y equals 3x plus 17. So in this case, our slope-intercept form was 3x plus 17. So our slope, remember, is always the number in front of the x. And our y-intercept is 0, 17. Now, the problem with this is that our y-intercept is too large, so we're going to go back up to the original point and use that to make a graph of our line. So our point is negative 5, 2. So we're going to go to negative 5, 2. And then we're going to use a slope of up 3 over 1 in order to get a graph on our line. Remember that we only need to do this if our y-intercept was too large to fit on the graph that we were given. So number 9, when I substitute in my points, I have y plus 8 equals negative 1/2 times parentheses x minus 4. So in order to solve for y, the first thing I'm going to do is distribute my slope of half. So y plus 8 is equal to negative 1/2 x plus 2. And then I'm going to subtract 8 from both sides, so y equals negative 1/2 x minus 6. So in slope-intercept form, my equation is y equals negative 1/2 x minus 6. So I have a slope of negative 1/2 and a y-intercept of 0, negative 6. So this time it's going to fit on the graph, so I'm going to go to 0, negative 6 and place my point. And then my slope was negative 1/2, so I'm going to go down 1 over 2, down 1 over 2, and then connect my line. So number 10, we're going to go the opposite direction now, and we're going to write the equation of the line based on the graphs. So if I look at my graphs, I need to find the slope and the y-intercept. So the slope, in this case, because the line is rising from left to right, I'm going to go up 2 and over 3. So my slope is 2/3. Now when I pick a point, it does not matter which point you use because the equation is going to end up working for both if we had to switch it over to slope-intercept form. So I'm going to pick the point on the left, which is negative 6, 3. And then I can write my equation in point-slope form. So I have y minus 3 equals 2/3 times x plus 6. And then I'm going to solve to move it into slope-intercept form. So I'm going to distribute the 2/3 first. So y minus 3 equals 2/3 x plus 4. And then I'm going to add 3 to both sides. So y equals 2/3 x plus 7. Number 11, this line has a negative slope because it's decreasing from left to right. So I'm going to see how much do I go down, which is negative 2, and then over 2. So my slope is negative 2 over 2, which is reduced to negative 1. Again, I'm going to pick a point. It doesn't matter which one I pick, so this time we're going to pick the one on the right. And that point is 3, negative 6. So when I write my equation in point-slope form, I have y plus 6 equals negative 1 times x minus 3. In order to get into slope-intercept form, the first thing we're going to do is distribute our slope. So y plus 6 equals negative 1x plus 3. And then I'm going to subtract 6 from both sides. So y equals negative 1x minus 3. So you can write it as y equals negative 1x minus 3, or you could just write it as negative x minus 3. Either one means the same thing still. So number 12, the slope of the line is 2 and goes to the point 4, negative 9. Does the line also go through the point 1, 1? So we can look at this two ways. First, we can graph using the slope and this point to see if we get to 1, 1. So I'm going to go to negative 4, 9, and I'm going to use my slope and to see if I can get to the point 1, 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So notice that we're at that point 1, 1 on the line. So we just showed graphically that that does work. Now we can also do it algebraically. So we're going to write the equation of the line. Y plus 9 equals 2 times x plus 4. And then we're going to test using the point 1, 1 to see if both sides of the equation are equal. So we're going to put 1 in for x and 1 in for y. We only put the numbers in here when we're testing, is it a solution or not? So when I substitute, I get 1 plus 9 equals 2 parentheses 1 plus 4. So 1 plus 9 is 10. And then we have 2 times 1 plus 4, which is 5. So we get 10 equals 10, which also means that it's a solution because it works in the equation.